Okay, this is the lesson for 5.5. I'm going to do this in two parts. The first part is going to be the side, side, side. And then the second part, which we'll use later on, is going to be the HL. So first of all, we do not need the vocabulary yet because the vocabulary goes with the HL, or the hypotenuse leg part of the lesson. So we just need to look at the theorem. The theorem says side, side, side congruence theorem. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So you have to get used to using the marks so that you know what you have. I advise drawing pictures. I advise making markings, and then you'll be using a two-column proof like we did and the algebra proofs. So in this case, they're showing you that you know that AB is the same as DE, so they marked that up one way. That BC is the same as EF, they marked that up with another set of hash marks, and then AC is the same as DF, which they marked with the third set of hash marks. So if you have that, you can conclude that triangle ABC is congruent to triangle DEF. Now, I'll be going through examples with you, but this is the beginning, or the theorem that goes with it. Okay, so just a couple ideas we need to talk about. They're asking on this page whether to decide if the congruent statement is true. So it says we're looking at triangle DFG. Is it congruent to a triangle HJK? So you can see here, I'm going to darken that up a little bit. We have two triangles, and if we look, we have hash marks on all three of them, so that we have DG is congruent to HK, we have FD congruent to JH, and FG congruent to JK, which means we have three corresponding congruent sides. So three sets of sides of the triangle that are congruent. So by the side, side, side theorem, we can say that those two triangles are definitely congruent. Okay, so if you look at number 2, we have a side AB of 3, side BC of 7, and side AC of 9. Now if you look at the second triangle, AC is 9, so that does set and match to the ABC triangle. AD is congruent to BC, however CD is not congruent to side AB, so we do not have three sets, so not three corresponding congruent sides. So in that case, so the triangles are not congruent. You have to have all three sides being congruent correspondingly. Okay, if you look at number 3, again we have PT congruent to ST, QT to RT, and PQ to SR. So in this case we have three corresponding congruent sides again. So by side, 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 we have two triangles that are congruent. So you must end up having all three sides in order to make that work. Okay, just a little picture type thing. It says explain why the bench with the diagonal support is stable while the one without the support can collapse. So here's the bench. I don't know if you can see it, the picture's a little dark. Here's the diagonal. I'm supporting this bench, and then we have another bench over here that does not have a diagonal. So the bench with a diagonal, if you look at it, it forms triangles with fixed side length. And if you look at those triangles are going to have congruent sides, because these two sides are going to be congruent, these two sides are going to be congruent, and then they share their hypotenuse. So by the side, 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 the bench cannot change shape, and we have two congruent triangles. So the bench is going to stay stable because the congruent triangles are not going to change shape. where on the other side this could tilt and it would not stay the same shape. So it does not have the same stable on it, or it's not stable as this one is. Okay, again, more pictures, just a little talk about what looks stable and what does not. Okay, number 4, again, there is no diagonal, so that one is not going to be stable, because again, you could be sliding it a little bit to the side and have it look more like a parallelogram. Number 5 is a little deceiving. The picture is a little bad, but if you do make the diagonal there, it does form 2 congruent triangles. And this is just like the bench. So in this case, of course, it is going to be more stable. And then number 6, we have 1 triangle, but not a second one matching it. So this is not going to be stable either, because we do not end up with congruent triangles. So just another way of looking at what we're working with, which is the 2 triangles must have 3 sides to be congruent. So they are something like this, which would be much more stable. Okay, we're going to write our first proof. Now you've done the 2-column proof before, so we make our 2-column proof, and number 1 is going to be our given. So KL is congruent to NL, and we also know that KM is congruent to NM. Now if you want to put those both in the same number 1, so you only have to write given once, it's perfectly fine with me. I guess I'm just going to spread it out so you see what I have. Okay, so we have KL and NL, we have KM and NM. Now, we have this piece in the middle that is shared by both sides, so by our reflexive property, LM is congruent to itself, and if we make markings on it, we actually have 3 sets of sides, so triangle KLM is going to be congruent to NLM by side, side, side. Now, please remember when you're writing your proofs, number 1 should always be the given. The last line on the left should always be the prove statement from the proof. Okay, so our extra practice that we're going to do, we're going to decide first of all for 1 and 2 if they are congruent, and then explain the reasoning. So if we look, we're trying to decide if ABC is congruent to EDC. And again, if you look, they're both isosceles triangles, but we have one side congruent to one side, a second side congruent to a corresponding side, and then the third side corresponding to the third side on the other triangle. So the congruence statement is true, and it's due to side-side-side congruency. Okay, if you look at number 2, again, we have GH congruent to JK, so we have one set of sides. We have GK and HJ congruent by another set of markings, and we share a third side. So again,